Experimental investigation of influence of fiber in foam concrete. A final year project done by N. Ragavan, S. Gopi and D. Thangathurai under the guidance of Mr. B. Mohan M. Tech. Concrete having density ranges from 400 to 1800 kg per metric cube are generally called as lightweight concrete. The concept of lightweight is to reduce the density of concrete results in reduction of sulfate, thereby reducing the concrete and reinforcement in beams, columns and foundations, which brings in economical construction. Lightweight concrete can be produced by two ways: using lightweight aggregate by replacing the normal conventional aggregate, and by using aeration by chemicals and foaming agent. Foam concrete. Foam concrete is a versatile material which consists primarily of a cement-based mortar mixed with at least 20% volume of air. Foam concrete can be produced by two methods: pre-foaming method and post-foaming method. Pre-foaming method is the method in which the foam is generated separately and mortared separately and then mixed to form foam concrete. Post-foaming method is otherwise called as mixed foaming method, the method in which foam concentrate is directly added to cement mortar mix to produce foam concrete. This flow chart shows how to make foam concrete using pre-foaming and post-foaming method. Some advantages of foam concrete are reduction in dead load, requires no compaction, water and frost resistance, high thermal insulation, saving material, saving time and cost, and minimum investment. Problem statement: normal concrete with natural aggregate has density ranges between 2200 to 2600 kg per meter cube. The self-weight of the conventional concrete results in high load on structures. By using foam concrete, it is possible to reduce the dead load by 40%, resulting in saving of materials in beams, columns, and foundations. But foam concrete could not be able to attain the M20, which is normally used in construction. To overcome this, we are adding fibers to foam concrete to enhance its strength. Materials used: Portland Pozzolana cement of 53 grade, fine aggregate passing through 2.36 mm sieve should be used, binding wires and glass fibers, and the foaming agent Natpro 800. These are the figures shows the fiber material, binding wires and glass fiber. The properties of foaming agent we used are highly water soluble and miscible, biodegradable, can be easily handled without fear of toxicity, dosage requirement is comparatively less, which makes it cost effective, contains peptides of different molecular weights, produces stable and homogeneous air bubbles. Mix design. At present, no guidance or standard method for proportioning of foam concrete, because the hardened density of foam concrete depends on saturation level in its pores. However, optimum ratio is taken as 1 part of cement, 1.5 to 2 part of sand, and 0.45 to 0.46 as water cement ratio. This is taken from our reference 1 and 2. Specimen details. The concrete cube of size 70 mm by 70 mm by 70 mm cube is casted with two different mix by varying with and without addition of fibers, and by varying water cement ratio as 0.45, 0.5 and 0.55. The total number of cubes casted are 72. This chart shows the density of mix 1:1.5 after 3 days and 7 days curing. It is observed that the normal foam concrete specimen comes within lightweight limit. This flow chart shows the density of mix 1:2 after 3 days and 7 days curing. From density, it is observed that the density of 0% fiber mix comes within lightweight limit. When adding binding wires, the density of the specimen exceeds its limit. This is because during mixing process, the fiber material collapses the air voids present in the concrete, results in increase in density. As a consequence, it fails the lightweight concept. To overcome this, we selected glass fiber as an alternative. Specimen details. The cube size of 150 mm by 150 mm by 150 mm is casted with the mix ratio of 1:2, water cement ratio of 0.5, and the addition of fibers as 0.15% and 0.2%, and without addition of fibers. The number of cubes casted are 9. This chart shows the density of specimens with and without addition of glass fibers. This chart shows the compressive strength of the specimens after 7 days, 14 days and 28 days curing. Results and discussion. The foam concrete specimen attains 30% in 7 days curing, 70% in 14 days curing to the strength attained in 28 days. Compared with conventional concrete, the strength attained by the foam concrete is low. The observed density ranges from 1600 to 1800 kg per metric cube, which are suitable for load-bearing structures. The normal foam concrete specimen of density 1800 kg per meter cube have the compressive strength of 15 Newton per mm square. But fiber reinforced foam concrete of 1600 kg per meter cube have the compressive strength greater than 20 Newton per mm square, which is equal to M20 concrete, which is normally used for construction. From this, it is observed that dosage of fiber decreases the density and increases the compressive strength. Conclusion. The concept of lightweight fails when binding wire is added as a fiber. Dosage of glass fiber decreases the density and increases the compressive strength of foam concrete, such that 70% increase, which brings in strength equal to normal conventional concrete. This can be applicable for concreting in roof slabs and load-bearing structures. These are some of my reference of my project.